Here are the answers to your 5 a day. Let me know if you have any questions about those. So today we're going to have a look at a few more different types of graph that we can draw using polar coordinates, in particular the cardioid, spiral and rows. So let's start with the graph of r equals sine 3 theta. So to work this out, our angle that we're plotting only needs to go up to 2 pi, as this is a complete turn. As the angle in our equation is 3 theta, then our steps are going to go up to 6 pi. We're going to go in increments of pi on 2. So here's our table. To plot our points, we need to have theta. So I need to divide each of these by 3. And then I substitute the values, my top row, into my equation to get my values of r. So you'll see this kind of up and down or swinging between or oscillating between 1 and -1. That happens because that's what the sine graph does, moves between 1 and -1. So now let's have a think of plotting these. We're going to do it in several sections. So let's look at this one first. We start at 0, 0. As we move round to pi on 6, we move out to 1. And then we move back to 0 again. I'm going to skip over the -1 for the moment and jump to this section. As I move out to 5 pi on 6, I move out to 1 and then back to 0 again. Then I'm going to skip over this -1 and for this section here. As I move out to 3 pi on 2, round to 3 pi on 2, I move out to 1 and then back to 0 again. Like this. So as my angle increases, the distance does up until pi on 6 radians, and then it starts to decrease again. Then I repeat that pattern 3 times until we get back to the beginning. In fact, that's not quite what happens. If I look at this first section of my graph of sine 3 theta here, that corresponds to this section. I start from 0, I move out to 1, then I move back again. Now this second section of the graph here does actually correspond to this part of the graph. Remember that when r equals -1, that's like moving backwards. So if when I move to pi on 2, I move out to -1. So -1 from pi on 2 is down here. So if I was tracing the graph out, I would go round like this and then round like this. So I move out to -1 pi on 2 and then back in again. Then this part corresponds to this part. So I'd actually draw over this line twice as I move between 0 and 2 pi. It's just easier, so the way I drew it, it's easier to think of things that are positive, so that's why we drew it that way. Okay, so let's have a look at this equation. This time we go up to 2 pi, so in our table of values we'll go up to 4 pi. For plotting we need to have just theta, so we'll divide everything by 2. And then substitute my values of 2 theta in to get r in terms of a. Now, here and here, when I substitute pi and 3 pi into my equation, I would get a negative that I would then need to square root, which I don't know how to do that. So we're not going to plot those points. So I start at A when my angle is 0, and then I move into 0 by the time I get to pi on 4. Then I move out to A as I move round to pi, and then I move round to 0 again, back to 0 again. And then from 7 pi on 4 out to 2 pi, I move from 0 to A again. And so that gives me this shape. This shape is called a lemniscate. You might recognise it as the infinity symbol. You'll have a look at making your own one later. Here's another type of equation. This time we've just got one theta, so we can just work out values up to 2 pi. Substitute them in to find r in terms of A. Then let's plot them. It joins up to make this shape. So as our angle goes from 0 to pi, the distance of the line from the origin becomes smaller. Then as we move from pi to 2 pi, the distance increases again. What we get is this shape. It's slightly more squashed on this side than it is on this side. Now here's a similar but slightly different equation. Let's have a look at what this one looks like. Plot the values. Now what happens here is you actually get this dimple going on rather than the kind of flatter version that we had before. So let's have a look at graphs of this form. So when P is less than Q, we're not actually going to look at that today, but you can, when I show you how to do this on your CAS, you can pop it into your CAS and have a look at what they look like. When P is equal to Q, we'll get a value of 0 for the distance at one point. That's when theta equals pi, because cos will be -1 at that point. Therefore, P minus Q cancel out as they're equal, and that gives us this cardioid shape that we saw before. When P is between Q and 2Q, we get this dimpled shape. Looks a bit like a bean. When P is greater than 2Q, we get this egg shape. And the bigger P is, the wider the egg gets. And if we did this with sine instead, we'd get the same idea, just everything rotated 90 degrees anti-clockwise. Okay, so this is how we do it on our CAS. If you go to a graphs page, menu, graph entry edit, polar, then it will give you this r1 theta equals. You can type in the equation. The theta is in the pi button. You can change the domain and the step size, but 0 to 2 pi and 0.13 are good for most purposes. And then it might be that you need to zoom in or out to be able to see your graph better. You can trace points on the graph using trace, which is in menu. You can also go to specific points. So, for example, if you wanted to go to where theta equals pi, you just type pi in and press enter. You can see that it's jumped to pi there. So, here are some shapes. So this is for cos and this is for sine. What I want you to do is investigate the relationship between n, the number multiplying the theta, and the number of petals or leaves. So these are called roses. This is a trivial rose. It's a circle. So these are circles that don't have centers on the origin. Their centers are on the y-axis or the x-axis. And and so that comes from r equals cos theta and sine theta. Yes, so investigate on your CAS, or you can do this by hand. What's the relationship between the number multiplying theta and the number of petals? So hopefully what you found is that when n is even, they give a 2n leaf rows. Leaf, petal, sticky outy thing. So these 2 theta graphs have 4 petals, and these 3 theta graphs have 3 petals. And so they give an n leaf rows when n is odd. Okay then, so now you can have a go at questions 2 to 4. Please pause the video while you do this. Please do these without your CAS. Then this link here takes you to a place where you can play around a bit more with having a look at different graphs of polar equations and matching them up. These are the answers that you should have got for 2 to 4. Now have a go at questions 1 to 5. And this is what you should get. So, some other polar graphs. This is tan of n theta. Here's our spirals. This is just r equals n theta. Got ever increasing circles here, just n cos theta or n sine theta. And these are also called roses, and this is what happens when we use a non-integer value to multiply the theta. And so you can investigate what's the relationship between, so if we have a over b, what happens when a is less than b, what happens when a is greater than b, what happens when they're odd or even, and so on. Okay, let me know if you have any questions. Thank you.